Hi. So in this video, we're going to work through lesson 3A.3, finding flat surfaces. We want to identify whenever we found a flat surface and understand how to visualize that, as well as how to place assets on these planes that we've found. So let's go ahead and create a new Xcode project. And we want the augmented reality app template, and we'll choose next. I'm going to call this plane detection, and we'll go ahead and save this to our desktop. Let's go over to our view controller, and we want to enable a few debug options. The debug options allow us to see additional things on the screen. We can do this by, in our view did load, under the scene view, we can add another property, scene view debug options equals, and then this takes an array, and it's an array of AR scene debug options and show feature points and AR scene debug options show world origin. Next, as part of tracking, what we want to do is identify and show the plane anytime a plane has been detected. So down here in the view will appear method, part of the AR world tracking configuration, we can set a property to enable plane detection. So we can say configuration dot plane detection equals, and then this is an array, and we want to detect horizontal planes. Now, because this view controller is a delegate of AR scene view delegate, there are some events that get triggered whenever a plane is detected and when things within the scene change. So we're going to work with a couple of these renderer methods. Specifically, we want to create one for renderer, and if we start typing, notice that it's going to give us code hints, and we want renderer did add. And within this method, what we're going to do is detect whenever a plane is found. And so the way we'll do that is we first create a guard let plane anchor equal anchor as AR plane anchor, else we return. When this method gets called, we want to print a statement, a new plane was discovered. Okay, let's go ahead and run this. And here we have my messy desk. And notice we're getting these point detection, which are these little yellow dots that are feature detections. And then as we move around, we look at the floor, we look at the table. Notice over here it's showing that a new plane was discovered. So we are getting some kind of recognition. Well, it's nice that it's told us that it found something, but the question is, how can we see it? So in order to do that, what we will do is create a plane and add it to the scene. We're going to create a method, and I'll just add it up here. We're going to create a floor, so we're going to call this function create floor, which returns a scene node. We're going to say let node equal scene node, and for geometry we're going to say let geometry equal scene plane, and we're going to set a plane that is a width of 1 and a height of 1. Then we're going to set that geometry to the node. Then we're going to rotate this plane. So we're going to say node dot Euler angles dot x equals, and we're going to say negative float dot pi divided by 2. And we set the node opacity to 0.25. And then we return this node. Okay, so here's our method that will create a plane and set it to a certain size and transparency. Next, we need to update our did_add method. And so every time there's a plane is discovered, we now want to create a floor and add it to the scene. So we will say let floor equals create floor, and then node dot add child node floor. Let's run this. So, okay, so now we have a plane that was detected. Now notice, oh, now we got another plane. So that's all well and good. So now we can see that. The only problem is, notice that the plane is one size, and depending on its location, its size, it's not changing. If I had a cleaner desk and a larger table, you would be able to see as it would find more planes detected. So let's fix this. We want to adjust the plane size as the detection of a plane and the dimensions are identified. So, for example, as you start to identify more flat surfaces in your camera view, you want to be able to grow and resize the floor to match the dimensions of what's being found. So with that, we're going to change our create floor method so that it accepts an AR plane anchor. So we're going to say plane anchor, which is of type AR plane anchor. And from there, let's update our geometry to take the plane anchor, and it has what is called an extent value, which is the size of the anchor. And the extent property gives the estimated width and height of the detected plane. So from there, we're going to cast this to a CG float, and we're going to say plane anchor dot extent dot x, and then for the height, we're going to cast this to a float plane anchor dot extent dot z. Okay, so we've updated that method. Now, of course, it's complaining down here because we need to now pass in this, and so we're going to update that reference and pass in the plane anchor. So now, to recap what we've done, whenever a plane is found, detected, then we're going to update the floor, and we're going to set it to the size of this geometry. Let's go ahead and run that. Okay, so now notice when it adds the plane, it is finding it in relation to the size of what it's discovered. Now, again, the quality of this detection, of course, is based on how clean your office is, how good the lighting is, and the quality of your phone, different things like that. So now what's happened is we've created a plane that has now referenced the size of when it's detected, but there's a capability to get more details as you expand into a larger desk or table or floor. You'll be able to modify that so that it changes as more information is added. So to do that, let's go back to our code. There is another delegate method that we can call for the renderer that is called update, did update. And here in the did update method, we can now modify the size of the anchor so that it reflects the new data that's been added as your camera finds more planes within view. So with that, we're going to say guard let plane anchor equal anchor as AR plane anchor, and then we're going to say let plane node equal node dot child nodes dot first, and let plane equal plane node dot geometry as a scene plane, else we're going to return. Now from here we want to set the plane node dot position equal to, we're going to set it to a vector 3, that is the plane anchor dot center dot x, then 0, and then plane anchor dot center dot z. Then we're going to set the plane dot width and cast it to a float. Oops. Come on. Cast this as a float. Plane anchor dot extent dot x, and plane height CG float plane anchor dot extent dot z. So what happens is, first we identify the first child geometry as a plane, then we match the node position and size to the anchor's node position and size. Now when we run this, we can see how the existing plane will grow as more information about the scene is discovered. Okay, so now notice how the plane is growing as more information is being found for this particular plane. Same thing happens here on the floor. Awesome. Next, we want to be able to position our assets in relation to the plane. So if we go into our art scene assets and we have our default ship scene, note that the ship mesh, there's the ship scene and the origin is over here, and notice that, remember that the ship mesh is offset. If I select the ship mesh and I come over here to my node properties, notice that the position is offset. I want to set this back to 0 and 0. What that does is matches the scene. So when I add this scene to a plane, it's going to be centered within that plane and it won't be offset. Now, in the same way that we created a floor and added it to the plane, to our scene based on the plane detection, we can create a new ship and add it to the plane. So if I go back to my view controller and let's create a new method, and this one's going to be called create ship, and it's going to take a plane anchor, which is an AR plane anchor type, and it's going to return a scene node. From here, we're going to say let node equal scene. Now what we're doing is we're getting the scene asset, and so we're saying named, and so this is art dot scene assets. That's the name of the folder it's in, and then ship dot scene. And from there, we're going root node dot clone. The reason we're cloning it is so that it makes a copy of this scene. Otherwise, if we didn't make a clone, it would just move the ship, and it would move every time it found a new, detected a new plane. And so in our case, we want to clone this. Now we set the node.position equal to, and we're going to set this as a vector 3, and we do plane anchor, similar to the other, to what we did with the floor, center.x, and then 0 for the y, and then z is going to be plane anchor.center.z. And then finally we return the node. And now this will stop complaining. In the same way we added the floor, we can also add the ship. So we can say let ship equals create ship, and then we pass in plane anchor. Then we say node.add child node ship. In our did update delegate method, we're changing the size of our plane. In the same way, we can change the position of the ship once it's been added. So in order to do that, what we're going to do is loop through the node child nodes, and we're going to update their positions. So let's modify the did update method in this manner. We're going to get rid of these references here and change this to a for loop. So we're going to say for node in node.child nodes, node.position equals, and then this is a scene vector 3, which is plane anchor dot center dot x, and then 0 plane anchor dot center dot z. Then we check if let plane equals node.geometry as a scene plane. Here, when we're going through these nodes, we've identified, so every time we add a floor or a ship, we have nodes within our renderer, with our scene renderer. And within those child nodes, we're updating the position, but then we're saying, okay, if this is a scene plane type object, then we need to modify the plane.width and set that. And we're going to say plane anchor dot extent dot x, and then the plane dot height cg float plane anchor dot extent dot z. Okay, so let's kind of review what we're doing here. We have a did add method that detects a plane. So let me start at the top. We have enabled debug options so we can see some feature points and show the world origin, so we can see things in relation to what the camera sees. Then we have turned on plane detection to identify horizontal planes within the scene. From there, we have we are listening to some delegate methods. One is called did add, and so from here, when we identify that a plane was found, then we're doing two things. We're creating a floor, and in this create floor method, we're just creating a plane and setting the geometry to the size of the plane anchor, and then we're adding it to the root, the scene, which is our main node, and as a child node. So then we add a floor, and at the same time, we're adding a ship. And in our method here, we're creating a ship, we're cloning it, and then we're adding it positions centered on that plane. So that is the initial, anytime something is found, it adds a floor and a ship. Then in the update method, in this delegate method, we are looping through the child nodes, and for every ship, we're updating the position so that it's always centered. And for every plane, we're updating the plane width and height to match so that it's taking up the full width of that plane, so that we're not creating multiple planes on the same level, if that makes sense. So this will continue to update everything in the scene. All right, let's go ahead and run this. So now, okay, notice, first of all, we have this ship here, which is because of the way that we've added it to the scene, so it's centered at the origin. But if we look down, and now that plane has been detected, notice that it updates the size. And if we look at the floor, then hey, look, it found a floor plane and the ship, and it's updating its size as it identifies more information. Awesome, pretty cool. So what we're left with is the ability to detect planes and surfaces, and we can add assets and update accordingly. Well, thank you for watching. I hope that was helpful. We're going to continue through the rest of these lessons and get to the main project for the AR kit, and it'll be a lot of fun. Be sure to like, subscribe, tell your friends, tell your neighbors, and yeah, thanks.